We're looking at the second function here and how we got those results for the intercepts and for the asymptotes. So I'm going to move over to my document camera. Excuse me. For the y-intercept, we want to leave y alone, and we want to set x to be 0. And if I work that out, 0, 0, 0 squared is 0, 0 minus 16 is negative 16, and 0 divided by anything, always 0. And we can always take nothing and divide it any way you want. Everybody gets nothing. So that works just fine. So our y-intercept is going to be, well, x is 0, y equals 0, 0, 0. There's a y-intercept. The x-intercept, so again, we want to set y equal to 0 in this case, and we want to leave the x's alone. We could either try and solve for x, or we could just ask something divided by something equals 0. The only way to make that happen is if it's 0 divided by something. 0 divided by anything is 0. So if we can make the numerator 0 divided by something, we'll get the 0 we want. So what would make the numerator 0? Well, if x was 0, then we'd be good. 0 divided by 0 squared minus 16. The only thing you really have to be careful of in setting the numerator equal to 0 is make sure that the denominator is not also 0, because 0 divided by 0 is a problem. We already did this up in the right up here. We know that equals 0. So if x is 0, y is 0, it works out. Okay. Or if y is 0, x has to be 0. And we get our x-intercept being 0, 0 as well, which makes sense because here we go, 0, 0, 0, 0. We got the x and y intercepts by replacing x with 0 and y with 0. Let's find the asymptotes. So the vertical asymptote. Remember, the vertical asymptote is where we want to basically try and force the problem to happen. We want to say you can't divide by 0, so let's see what domain value, what x value would make that happen, because that's the one we can't use. So we're basically trying to find the problem by forcing the problem to happen. So we are asking what values for x, what domain value would give us a 0 in the denominator. That's our question. So I'm going to set that denominator equal to 0, because that's really what I want to know, is what would the x values be to make it that happen. If I solve for x, I'm going to get x squared equals 16. And I happen to know that 4 times 4 is 16, but I'm going to take the square root of both sides, and I'm going to get plus or minus the square root of 16, which would be plus or minus 4. Be careful with that. Plus or minus 4 if you take the square root of both sides. The other way to look at it is this is a difference of perfect squares right here. X squared is x times x. 16 is 4 times 4. So this would be like x minus 4 and x plus 4 equals 0. If we use our zero product property, x would have to equal 4, or x would have to equal negative 4 to make that equal 0. So you could solve it in either way. I went up this direction to get my answers of 4 or negative 4, or I solved it going down in this direction and got plus or minus 4, same thing. Regardless, the vertical asymptotes would be at the line x equals 4. You have a vertical line straight up and down at x equals 4. And you'd have another one at x equals negative 4. Maybe another one. I'm going to show what that looks like here in just a minute. So we got our vertical asymptote. Let's find the horizontal asymptote. I just drew this line here to separate. As I was saying horizontal, I know I was drawing a horizontal line, but that was just coincidence. I just wanted to separate this. Horizontal asymptote. So the rule was if the degree of the numerator was the same as the degree of the denominator, then we look at the coefficients, the leading coefficients. If the degree of the numerator is less than the degree of the denominator, the degree of the numerator here is 1, the degree of the denominator here is 2, so less than the denominator, then the horizontal asymptote is going to be at the line y equals 0 or the x-axis. And so that was just using the rule to find that horizontal asymptote. And that's all you were asked to do in this problem, just to give you a visual. And I don't know if I showed it in the first example, if you watched the first example video, but this is what, so x plus 4 over x plus 2 looks like this. You can see the vertical asymptote at -2 here, and the horizontal asymptote at y equals 1. This is what the one we just did looks like. You'll see that there is a vertical asymptote here at -4. Never quite gets to -4. There's a vertical asymptote here again at 4. The horizontal asymptote, as x gets super duper 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 big, the values get closer and closer and closer to 0. And as x gets super duper 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 small, x gets closer to 0. So it does cross the horizontal axis or horizontal asymptote, and that's okay. The horizontal asymptote is looking at the extremes of when x is big and small.